Direct proofs are used to prove statements of the form P implies Q, or if P then Q. This is one of the most common methods of mathematical proofs. To understand how direct proofs work, let's take a look at the truth table for implication. For this conditional statement to be proven, we must show that it is always true. We can see from the truth table that the only concern we have is the possibility of P being true and Q being false. We therefore have to show that if P is true, then Q must also be true. This is what direct proofs boil down to. We assume P to be true, and then we have to prove by logical deduction that Q must also be true. We don't concern ourselves with the possibility of P being false, because if it is, the conditional statement is true anyway. So let's take a look at an example. Prove that if n is even, then 7n plus 4 is also even. We start by writing the proposition. If n is even, then 7n plus 4 is even. Then we add the definition we want to use. An integer x is called even if there exists an integer k in the set of integers such that x is equal to 2k. Now we start our actual proof. We start by assuming that n is an even number. As stated before, we don't concern ourselves with the possibility of n not being an even number, because if it is, then the conditional statement is true. We can then say by the definition of an even number that n is equal to 2m, where m is an element in the set of integers. We can then show that 7n plus 4 also has to be an even number. We start this by substituting n with 2m, then we remove the parenthesis by multiplying, and then we factor out 2. Then we substitute 7m plus 2 for k to show that the expression can be written as 2k, where k is an integer because m is in the set of integers. We can then say that 7n plus 4 is equal to 2k, where k is an element in the set of integers by definition is also an even number, and our proof is ended. Now that you've seen an example on how to write a direct proof, you can try this exercise on your own. Prove that the product of an even number and an odd number is even. Take a few seconds to try this out on your own, and I'll show a solution in a few seconds. We start this proof by assuming that m is an even number and that n is an odd number. Again, we don't concern ourselves with the possibility of this not being the case, because if it isn't, then our statement still holds. We then by logical deduction show that the product of these numbers also have to be even. If you got it, then good job. If you didn't, with enough time and practice you'll be able to do these proofs in minutes. If you have any questions, then post them in the comment section below, and watch the next video on how to write proofs by contradiction.